Anyway, don't worry about it. Okay, so tonight what I want to do is first start by dealing with any lingering issues or resolve any issues you might have for modules 1 and 2, or the labor market and marginality. You've already done your quizzes now, you've done your review problem, you'll see what you did well, you'll see what you didn't do well. I've scored those now, I scored them earlier today, so if you haven't seen that, those scores are up. And then we'll just launch right into modules 3, which is on evaluating labor market models, and then module 4, labor demand, and module 5, labor supply. Okay? And obviously, in this kind of a format where I've expected that you've reviewed the videos in advance, I'm going to hit what are the highest points and drill down where I think we really need to, but I'm not hitting everything that's in the videos. Not even close, right? Which means if you've got a question about some of that material, you've got to ask me. And I'll handle anything you want. Bailey, you don't realize this perhaps, but my expectation is we typically are out of here by 8:30, maybe even a little bit before. I'm happy to stay as long as you want and need me to, but absent extraordinary discussion from you, we just don't need to be here the whole time if you've prepped. If you haven't, it'll extend it for all of us, and we'll know who the guilty party is. Okay, so any lingering questions about labor markets or marginality? Please.
So I might have to leave a little bit early today too, so I'm sorry.
Okay, all right, thank you.
Can you give me just the definition of marginal revenue product of labor again?
Yeah, you
For
bet.
some reason that's just throwing me for a
You'll get this. So you as a worker, because your productivity or production ultimately is sold to a customer, right? You manufacture a widget, you provide a consulting function, you serve a table, whatever it happens to be. Ultimately, something of what you do is going to be bought by a customer. And there's revenue that changes hands that comes in because of that, right? Well, part of that revenue is paying for you and your wage, your productivity. Part of it's paying for the other inputs. Let's say we're manufacturing boats. So there's fiberglass and steel and an engine and plastic and leather and all this stuff, right? But there's also labor. So the marginal revenue product of labor is labor's contribution to, or that part of the revenue that is because of labor. It's not because of profit. It's not because of paying for the other inputs. It's because of the part that was created by and is responsible for labor. Can I help?
Yeah, that does.
Okay.
Yeah.
So the labor of making and like...
The labor of whatever it is. So you might be the president of the company. You're putting in labor, right? It's awfully difficult to see in that boat that was manufactured where your labor exists. So, but your labor does exist. You're running the company, and but it's hard to see what your productivity is. Whereas maybe you're actually one of the production people on the line, a skin in the thing in fiberglass. That's easier to see. But everyone in the company has to have some productive purpose. Otherwise, why are we paying them, right?
So it's the revenue that comes as a result of that.
Part of the revenue that comes as a result of the worker, not all the other stuff. And we can measure it for anyone. The less directly connected to production the worker is, the harder it is to measure, like a CEO or a secretary. But somebody on the production line, it's easy, right? I'm responsible to skin 3 boats a day, or whatever it happens to be. Okay? What else? Anything? Remember the labor force participation rate components as we go into the next modules, because they're used again. So the number of people that are employed plus the number of people that are unemployed equals the number of people in the labor force. The number of people in the labor force divided by the number of people in the population ages 16 through 65 is the labor force participation rate, or the part of the population that's of supposed working age that's actually in the labor force. And unemployment and employment just fall from all those. So you're going to see some of that again. Okay? So the next module, evaluating labor market models, really is all about what can we do when we have a series of two equations and two unknowns. When we have that, we can set up some really rich elements and that we're going to use over and over. In fact, this is a critical building block of this class. So whether it be tonight or any other time, I'm going to ask you maybe to kind of come out of the line of the camera. My guess is
Figure out it'd be just easier for you to look on one side.
Well, it is. Thank you. It is. We're going to look at those equations and see what we can do with them, okay? Because you're going to do it over and over and over again. And part of what you might have learned to do from other economics classes and the convention of labor economics may be enough different that I want you to get used to the convention. And when I say convention, part of that's about calculating, and part of that's about communicating. And so you might come up with the right numbers, Bailey, but if you don't know how to communicate them in the right way, then the reader doesn't know what you're talking about. Or maybe you come at it from an engineering or a mathematics background, and you believe that an equation starts with the y value, or the dependent variable on the left-hand side, and it's y equals this string of x's, but it's just the opposite in economics. X equals some string of y's or other things, perhaps. Okay, so we got to kind of get used to that. So let's look at this, and I just want you to believe me for a moment when I tell you that we have a labor supply and a labor demand equation. We're going to understand those better as we go through the modules. But just believe me when I say that labor supply can be equal to something. Excuse me, I have these backwards here, so pardon me. Anyway, some constant minus a scalar variable times a wage. So labor demand in this case, L being units of labor at some level, is equal to some constant minus some scalar times the y-axis variable. And labor supply, in this particular case, again, is some constant plus some scalar times the y-axis variable. So what we're setting up is, in the vast majority of what we're going to do, we're going to have labor or units of something on the x-axis, and we're going to have wage, which is the price of labor, on the y-axis. Okay? There will be a couple of times later in the term where we will perhaps have a monetary value on the y-axis and a monetary value on the x-axis, but that's kind of unusual. Most of the time it's going to be monetary and units, such that we're really measuring money, because money times quantity is still money, right? Okay, so just kind of keep that in mind. If we were to go ahead and graph these, which we will in a few minutes, we would see a couple of things emerge. Amongst them being that a labor demand curve is always downward sloping. And we know it's downward sloping because the sign in front of the scalar in front of the y-axis variable. And similarly, labor supply is always upward sloping. So let's kind of start there. Why is labor demand downward sloping?
So I know that they're not going to want to demand more labor at a higher price. So as the wage, goes up in that scale or in that graph, they're not going to, just basically a company isn't going to want to pay more for at that high of a price.
Okay, so I mean that's true. There's something else going on here. Think back to the marginal product of labor. Mike, come on, please. As more units of a good become available or become utilized in production, we suppose that every additional unit has a positive contribution to production or productivity, but not as much as the one before it, right? So think about as we add more labor units when we've already kind of utilized the footprint of our capital. This was a sandwich shop example, right? every additional unit gives us some more production, but not as much as the one before. So we have declining marginal product of labor. Well, if we have declining productivity as we add more, adding more, going this way, right? Then we want to pay less for it. It's less productive. And so there's an inference, there's a connectivity there. So at a point, you'll almost certainly have an opportunity to ask the question, why is labor demand downward sloping? And if you simply say declining marginal product of labor, or declining marginal productivity, or declining marginal utility, well, any of that, which really is all meaning the same thing, you will have correctly answered the question. Now you might go into a multi-paragraph discussion as to why. You're not going to answer the question any better than if you simply said, because of the declining marginal product of labor. Because that's why a labor demand curve is downward sloping. Okay? We have to think about why a labor supply curve is upward sloping as well. We're actually going to talk about that in one of the other modules tonight. Okay? But just trust me as I tell you, and those of you that have had the economics recognize this kind of graphic very quickly. Trust me as I tell you, the supply curves are upward sloping, demand curves are downward sloping, such that at some point in this universe they are going to intersect. What we're really looking at here is simply a Cartesian coordinate, such that we have positive space here. These axes continue on as far as we want them to continue to perpetuity, actually. We have negative space. I get this a little confused sometimes, excuse me. I believe we have positive space here and negative space here. I think that's the convention. But most of what we're going to deal with is going to exist in the positive space, because that's what makes sense. And we don't think about negative wages all that much. We don't think about negative labor all that much. Although we will infer a few things tonight that are a function of negative labor and wage. So remembering that, let's think about what we're going to do with these two equations. Sorry, you've just stepped into the room and I don't know your name. I'm terribly sorry.
My name's Catherine.
Catherine, you weren't here last week, were you, Catherine? Very good. So Catherine, I'm going to pick on you sometimes, and with such a constrained group, more often than if there were 20 of us. Fair enough?
Yeah.
Okay. I've already started picking on Bailey, but I'm going to try and relax a little bit.
Very good, do it.
Okay. So knowing that there was a point of intersection that we saw a moment ago, and you want to stay out of the line of the camera.
Okay, I just can't really, you're so tall, sorry.
Oh.
Okay, I'll move
No,
over.
you're good, no, you're good, I already moved, we're
Good.
good, yeah.
Knowing that we had seen this point of intersection before I erased this, we know that this labor supply curve at some point is equal to the labor demand curve. And knowing that, we can then think about being able to set these two equations equal to each other. A tremendous amount of what you'll do in this class is setting two equations equal to each other so you can find the solution to one of the variables that then leads to the solution of the next one. Okay? So Catherine, if I do that, I've got 500 minus 45W being equal to negative 200 plus 25W. What do I do next?
Solve for W.
Very good. How am I going to do that?
So add 45W to that. Well,
Okay,
yeah.
so I'm going to have, what's that, 70W over here? And then add 200 to both sides?
Yeah,
Okay, so 700 equals, now what do I do?
divide by 70.
So I've got 70, and I now equal W, or W star is equal to 10. When I say star, I mean equilibrium level, I mean market clearing level. These are interchangeable terms, but you'll use the convention of star. So when you give me something that is W star, L star, it means the market clearing or equilibrium level of. And if you simply on a graphic tried to, come over here, tried to define that point, and if you simply call it W, then that isn't good enough, because it's not W, it's W star. It's the market clearing level thereof, okay? So I can find W star, which is cool. And in this case, it's 10. I can't remember your name.
Nathan.
Nathan, I'm working on it for about 20 minutes, Nathan, and I had to do this. Okay, so Nathan, now I got W star, what do? I want L star.
I was actually just wondering the same thing. I can't remember.
Okay. Bailey, do you know what I do?
Actually, no.
Okay. Courtney?
I mean, besides plug it, if you plug it in.
Yeah, that's what I do.
Okay.
So tell me, plug it into what, when, where, how, why?
For W on labor demanded and
Okay.
labor supply.
So does it matter which one I plug it into? Why not? These look like very different equations to me.
Because you found W for both of them, it's the same.
Okay, and
Equilibrium.
since it's the equilibrium, at this point, I'm almost wishing I had erased this now, but at that point that used to be sitting here on the board, they are the same thing. And if they're the same thing, it shouldn't matter which one I plug it into, okay? So if I want to find L star, I'm going to then say L star is equal to, in this case I'll say 500 minus 45 times 10, or 500 minus 450, which I think is 50. So that's my L star. So I've got a number here that's going to be L star is equal to 50, or you could just as easily have said 50 equals L star, okay? It's not L, it's not labor, it's L star, all right? And the way that I'm about to show you this graphic, which will not be artistic, the handwriting's not very good, and even though I try to do straight lines, it's an attempt rather than a certainty, and you're about to see, just like I do on the videos, my curves are not going to be proportional and exact, and yours can be the exact same way. This is not a class in artistry. This isn't a class in how to use PowerPoint or any one of the programs that lets you do perfect graphics. If you have an upward sloping demand curve or supply curve, I'm good. If you have a downward sloping demand curve, I'm good. If you have properly labeled everything and given me values, I'm good, okay? So follow my convention and you won't lose points on exams. Don't follow my convention and you might, all right? So now I know I've got this point. That W star equals 10, L star equals 50, and I've got a point on my graph, okay? But one point isn't going to get the job done. I need curves. What do I do next? How do I get my curves?
Y equals mx plus b.
Yeah, so that's interesting. Y equals mx plus b, and that's a variation of the point slope equation, right? So let's look at that. Pardon?
And n. So
Well,
n, y.
yeah, and actually we're going to do it a little bit differently. We're going to say, I'm going to turn it around. Well, I'll leave it in this form for a minute. I want to have it be x equals some constant plus a scalar on y. This is y equals some constant plus a scalar on x. Yeah.
Could you just expand on why that is? Like why, I don't quite understand why we need to make X and Y switch.
Good question. Because the convention within economics is that we have an equation that is quantity of something is equal to some items and then, or some constants and something that affects price. The supposition being then that the X, or the quantity, is the dependent variable and it's a function of the price, or something and the price, right? Think about this. Catherine, do you set the price of the products that you purchase at the grocery store?
No.
No. You don't set them because you are one of millions of consumers buying them at the grocery stores around the country. You might even be one of 1,000 buying them at the Harmons in your neighborhood, right? But you don't set the price. The quantity that you buy, though, probably is a function of the price.
Yeah.
If the price is high enough, you buy fewer of them. So the quantity that we employ is a function of the price that we don't set. That's the inference, if that helps. I've never been asked that question, by the way. Good for you. I've been asked a few questions in this class over the years. Okay? So I want to rearrange this so that I have something that looks a little bit more like this. So to do it, I'm going to go ahead and subtract b from both sides. So y minus b is equal to mx, of x. And I can then divide both sides by m, or y divided by m minus b divided by m is equal to x. I turn that around, x is equal to, and I'm going to state it slightly differently, c minus, in this case, 1 over m of y. Or LD is equal to 500 minus 45W. Okay. So it's simply a point slope variant rearranged for the economic convention. And by the way, if you use Excel, as some of you might, to graph your curves, you have to remember that it's just the opposite of the way that Excel normally thinks. So when you have a graphic, you have to tell Excel which is the x and which is the y value. Otherwise, it'll be backwards from what you need. It's going to put your x value here and your y value here, and that's not going to meet our need. Okay? All right. So knowing that,
Actually, I have a question.
yeah.
When do the variables mean something, and when are they just variables?
In economics,
Yeah.
in everything that we do, they mean something.
Okay, so this is consumption. And
Yeah, so this is labor units
Right.
being deployed, consumed, employed,
Okay.
and this is the price of labor.
Okay.
So within what we do, variables will always mean something. They're not simply a substitution for some other string. That's a good question. Now, if you were to take a higher order, a version of this class, a master's level version, you're going to get into variables, maybe just being variables. Okay. Good question. So it's just part of a point slope deal, such that we can think about how we find now our slope and our intercepts and such. So think about this. If I want to find, for my LS relation, if I want to find where labor supply crosses the axes, because I know it crosses these axes somewhere, right? I can remember that at this point, right here, I'm at the 0, 0 nexus, such that if I have an intercept on my W axis, the value of L is what? 0. Or if I have an intercept point or something that's on my L axis, the value of W is 0. So knowing that, I can simply in turn set my variables equal to 0 to find what the point of intercept is on the other axis. So, and you'll see me do this in the videos constantly through the next month or so. I'll say if L equals 0, then 0 equals negative 200 plus 25W, or 25W equals 200, or W equals 200 divided by 25, or 8. And what I've just identified is for the labor supply curve, there is a point on the W axis that is equal to 8. And that point's going to be right about there. Right? I know it's less than 10. And then I can do the same thing. I can say if W equals 0, then LS is equal to negative 200 plus 25 times 0, or it's equal to negative 200. And I can then remember, this actually goes on for a ways. My guess is negative 200 is out about here. Right? So now I have actually 3 points for my labor supply curve. 1, 2, and 2 points are going to define my curve because these are linear equations, right? But I have a third one, and if I was a better artist, they would have lined up better, okay? So we're just going to say they do line up, and that's actually negative 200. And it keeps going straight, and that's labor supply. I'm going to do the exact same thing now with labor demand. such that I'll say that if LD is equal to 0, then 0 is equal to 500 minus 45W. 45W is equal to 500. W is equal to 500 divided by 45. Somebody with a calculator, tell me what that number is, please. 500 divided by 45. It's 11 something, I think.
11.11.
11.11? Okay. So now I know that on the W-axis, I've got labor coming through here at 11.11. Okay? And I can run the same game. If W is equal to 0, then LD is equal to 500 minus 45 times 0, or is just equal to 500, such that I know I've got a point out here at 500, and I can now take my points and I've set my intercepts, I've set my W star and L star, and I've properly labeled and articulated this model with the information at hand. Does that make sense? Get very comfortable setting two equations equal to each other to find one of two unknowns. If you have three unknowns and only two equations, you're in trouble, right? You need to use a calculus, and we're not going to do that in this class. We can talk about what these slopes are. We can talk about what they represent. We can talk about how we get them perfectly and why they're straight. I'm more interested in talking about what this means. Okay? You can get some of the rest of that in the videos, or you can ask questions and such. But what does some of this mean? When we have the supply curve transecting the wage axis where labor is 0 at 8, does that mean something to us? And if so, what do we think it is? Bailey, any idea what that might mean?
That's maybe the average wage.
It actually happens to be what we call the reservation wage. What it means is, at a wage of 8, let's say that this is dollars per hour for whatever this type of worker is, okay? And let's say that the number of units here are hours. By the way, a number over here needs to be defined as what it means. This might mean $800 a month. It might mean $8,000 a year. So you got to pay attention to what it's defined as, okay, in the problems that you're given. This might be number of people, it might be hours. And I'm saying in this case, let's say that it's dollars per hour. Actually, let's say it's workers. I'll make this a little easier, okay? But these are going to be defined. Well, in this case, at $8 an hour, 0 workers show up to work. The supply of labor at $8 an hour is 0. So it's a wage at which no one will show up. Anything above it then is a wage at which people, some number of people, maybe only one, will show up to work.
What was it called again?
A reservation wage. I reserve my labor for a price above this. At this number, nobody shows up. Okay? Well, there's an inference to that. So, Catherine, I'm going to suppose that you have monthly expenses that you or someone in your household really must meet, right? If you're one of these people that won't show up at anything at $8 or less an hour, and you might be, what is that suggesting? You still have your bills to meet. What's it suggesting to you?
That maybe I have really small bills, or I have a different worker that is working at the household and I don't need.
It could be either of those things. You have some other resources that you can rely on, which might be a function of society or a household member, savings, or hey, look, my rent's paid for the next 3 months because I paid in advance, and I got plenty of food in the cupboard, there's gas in the car, fine. You know what? You've got some resources at some level that you can rely on. You have some opportunities. You have some alternatives. Okay? Or it might simply mean that, Nate, you're thinking, you know what? I worked for years in college to get to where I'm at. I've then worked for years in the labor market to get to where I'm at after college. This is an affront, an offense to me, just on principle alone, I'm not showing it. Or any combination of those things and other things we might infer. Okay? But that's called a reservation wage. This is the market clearing wage. Let's define market here and separate it from firm, because that's about to become pretty important to you. I'm going to suppose at a wage of $10 an hour, that is the wage where everyone that wants to work is able to work, and there's no unemployment. Okay? That's what this is defining. If that's the case, my supposition is that this is a market for a relatively low-skilled or inexpensive worker at $10 an hour. Certainly not a physician. Okay? A single firm doesn't affect this market, does it? Just like a single purchaser of apples or anything at Smith's or Harmon's doesn't affect the price of the apple. It's an entire market of firms that affects it, which are then the firms that demand labor. A single worker doesn't affect this market, but an entire market of workers affects the market. So we're going to differentiate at times firms versus market and be cautious as you do that. Marginality is pretty much all about firms, not the entirety of the market, which is why we can say as you fill out those little tables that have labor and like the one on the problem set, it had a wage that was constant at $80 per, because no matter what the number of workers was, we had a constant wage because it was a competitive market, and it was a market that had set the wage, but the productivity is at the level of a firm, which doesn't set the wage. Okay? So with this, just with these two equations, we can set them equal to each other. We can find W star and L star, our market clearing levels. We can find our intercepts. With our intercepts, we can create our graphic model. And the extraordinary artistry with which that model has been created will get the job done for you to get all the points you might need to get. If you do it better, cool, thank you. If you do it sloppier, I don't know what you're thinking, okay? But these are the elements. I've labeled each curve. I've labeled each axis, and by the way, I've also put the axes in. When you have an exam with me, you'll see that when you have to do something like this, I give you on the printed page, because the exams are on paper, I give you a little bit of a graph in back of that, or some lines in back of that, so it's a little easier for you. And sometimes people will just put the curves in and some numbers and forget that they need to tell me where the axes are. And they think they're inherent. They're not. Okay, so give me axes. I even say in the instructions, don't forget to draw the axes, and I'll bet you about 10, maybe 20% of the students will forget to draw the axes. And it's in big, bold letters right now. These numbers, here and here, they mean something. This one probably means the most to us, right? Reservation wage. Here, this number means something to us. We don't label it based on what it means. I guess you could label this as a reservation wage. Here, this is simply saying that if a firm has to pay $11.11 a unit for labor, it wants 0 workers, right? And if a firm can get workers for $0, it only wants 500 of them. We think of, if I can get something for free, I want an unlimited quantity. But in this case, the firm doesn't want more than 500 workers. Why might that be?
Because of that same diminishing return.
Thank you. At more than 500 workers, we are not only not being more productive, we are robbing our productivity, which infers then that the labor demand curve is the same curve as the marginal revenue product of labor curve. So in a competitive market, the labor demand curve is the marginal revenue product of labor curve. It follows the exact same pattern. They are overlaid on top of each other. So we might have to think about how that is, how we get to that. Remember the conditions of a competitive market. We know that ME of L being equal to MRP of L, is a general market condition, right? And when marginal expense of labor is equal to the wage, we know it's a competitive market condition. And we know that when MRP of L is equal to the wage, it's also a competitive market condition. So generalized, so within a competitive market to not only competitive, okay? Well, I want to think about this labor demand deal. I'll use this right here as labor demand. I want to create a marginal revenue product of labor curve instead of a labor demand curve. So I've said they're the same thing. So how do we look at them? If MRP of L is equal to W, then I can simply substitute MRP of L for W in the equation, such that I end up with LD is equal to 500 minus 45 MRP of L. Now I still don't have an MRP of L equation, because for an MRP of L equation, it's got to be MRP of L equals something, right? So I'm going to rearrange this. I'm going to say 45 MRP of L is equal to 500 minus LD. I'm getting there. I'm not quite there yet. Now I can divide both sides by 45. MRP of L is equal to 500 divided by 45 minus 1/45 LD. Interestingly enough, I now have my point slope variant. Y equals m of x plus the constant. So I've rearranged this such that I'm back to a point slope form. And when I'm back in a point slope form, I can see the slope of the curve. The slope of this curve is negative 1/45. It's downward sloping. Okay? So that's an MRP of L relation coming from an LD relation. Please, Bailey.
So I'm probably just going to figure this out as I say it.
It's okay.
So you're not able to plug in just the MRP of L that you found, like say in that table we did, because just that's the actual solution there for the MRP.
Well, this is the entire curve.
Oh, okay,
And
gotcha.
you would have
So
found
that's-
a point
Okay,
on the
point
curve.
on the curve compared
Yep,
to.
exactly.
Could you just take those points on, like the table we found, but it doesn't have the second point.
If you found every one of them, because on there you had an MRP of L number and you had an LD number, right?
Yeah.
And if you plotted every one of those points, you would have plotted the curve.
Okay.
And in a linear curve, I call them curves even though they may be straight lines, right? In a linear relationship, 2 points defines the entire curve. You didn't have to plot all of them. Okay? But yeah, that's exactly what happens. Okay.
I've got one more question about
Please,
that.
man.
Just one step back.
Sure.
When you say competitive market, does that mean just a lack of monopolies, or what is the
That's a good
definition of
question.
competitive market?
So let's think about the conditions of a competitive market for labor. Plenty of workers willing to supply their labor. So nobody has any firm over the barrel. Plenty of firms demanding labor. No exogenous influences affecting the market. When I say exogenous, what do I mean? Courtney, do you have any idea?
No exogenous influences that
So no exogenous influences affecting this market. So nothing affecting the market coming from outside of it. So exogenous, X means from outside. Endogenous means from inside, or you might think of it as organic. Okay? So competitive markets are completely organic. Unfortunately, that one item alone tells us we do not have any purely competitive markets. Because governments, even if all they do is issue currency, or if all they do is set borders, those are influences, and we now don't have perfectly competitive markets. We may have relatively competitive markets. Perfect competition is a unicorn, okay? It's an ideal that we think about because we can see things from that ideal, and then when we relax the condition off of it, we see movements, and those movements are interesting to us, okay?
So it's kind of understood as like as competitive as it gets.
Well, yeah, and we're going to say our markets, we would like them to be as competitive as they get, But we're starting talking about purely competitive markets.
Yeah.
And when we relax that, it'll be obvious to you. We're gonna enter here in a couple of weeks, maybe next week even, into markets that have friction. And the friction, as you'll start to see tonight, is a function of some external influence. And I'll use an example of minimum wage as being an external influence. I'll do it in just a second, okay? So also competitive markets mean no barriers to entry, which is kind of hard because labor demand comes from firms, labor supply comes from individuals and households. In order to start a firm, you must have enough capital to put it together. You must get a business license. You must have some other things. So those are barriers to entry in our economy, in our market. So we want to have the least of those possible. Hi, how you doing? So those are competitive markets. And a competitive market creates labor demand, or creates L star, the market clearing number of workers, and W star, the market clearing price for those workers, their wage, if you will. And W doesn't simply mean necessarily the dollars per hour that they get in a paycheck. It means the entirety of the wage bill. So your benefits, your unemployment insurance premiums are paid by the firm for every employee. Your everything, including the dollars that you see on a paycheck. Okay. Let's talk about the effect of friction for a moment. When we get to that module where we talk about frictionalized markets, one of the things we'll talk about is a wage floor and a wage ceiling. And minimum wage is an example of a wage floor. So I'm going to ask you to think about a floor as something that you don't fall below. It's there to keep you up, okay? Well, a minimum wage would likely be set above W star. I'll call it WM. Let's say in this case it's equal to 12. No, it can't be 12. Let's say it's equal to 10 and a half. Why couldn't it have been 12? It's higher than the demand schedule. Yeah, exactly. Good. So it's going to come through here. Like this, isn't it? Such that the number of workers demanded at 10 and a half is less than 50. That's labor demand. And the number of the workers that want to supply their labor at 10 and a half is greater than 50. That's going to be supply. And when demand is less than supply, we have a surplus of workers and we have unemployment. It's as easy as that. Now there might be some automatic stabilizers and some other things that make that less painful, but that is the condition we're dealing with. How do I know how many units of labor each of these numbers represent? Each of these points on the graph represent? Any idea? You got to pronounce your name for me because I said it right 2 or 3 times last week and then I started saying it wrong and now I don't remember which it is. Vishwa? Okay. I'm sorry, man.
Okay.
That's really not. My father-in-law, when I first met him, I asked him whether he wanted to be called by his first name, which was Baron, or Dad. And fortunately, he wanted to be called by his first name. I already had a father, and I had a stepfather, and I had a different stepfather at another point, so I didn't need another one of these guys floating around. He wanted to be called by his first name. And then he told me that your own first name is the most comfortable word in any language to you. So I'm sorry to have obliterated it a few times last week. And I'll do it again. All right. So how do I find these numbers? Any ideas? Yeah.
Sorry, just another question.
Okay.
Is this representing the whole market?
This would be a market still. We're not at a firm level because if the firm doesn't set a wage, the firm would pay 10 regardless of the number of workers because the firms combined all equal a market.
And there wouldn't be unemployment in a firm?
Well, there can be unemployment in a firm,
Okay.
but it aggregates to unemployment in a market.
Okay.
Good question. So if I know that I have a labor demand curve dictated by a labor demand equation, and this point that we're dealing with is a function of that curve, and I know what W is, and I want to find L, I have an equation to help me do it, don't I? So I'm going to come up here. I'm going to use my labor demand equations. I want to find LD, and say LD is equal to 500 minus 45, not times 10 or W star now, but times 10.5. So what is that? So 45 times 10.5. So that equals 27.5. Which makes sense. It's less than 50, right? I can do the same thing with labor supply. I can go ahead now and put that wage, 10 and a half, and I can say negative 200 plus 25 times 10 and a half. So 25 times 10.5. 25 times 10.5 minus 200 is 62 and a half. Which makes sense because it's greater than 50. And all of a sudden, I now know how many workers, or how many worker units are unemployed in this market. There are the difference between those. Or I have 35 workers equals the number that are now unemployed. Remember, I simply used this value that was exogenously given. I simply gave it off the top of my little head, right? Which I think is somewhere the numbers come from when they come from legislation, off the top of somebody's little head. Okay? And I know that I have a relationship in an equation that creates this curve. So I simply put that number into that relationship and I solve for the remaining variable. What if I now wanted to find, for whatever reason, this point? Right there. How would I find that one? What do I know about that point?
27 and a half in the labor curve.
Or it represents 27 and a half units of labor, right? We happen to have got that from the demand relation. Is this point a function of the labor demand curve now? Or is it a function of labor supply? It's on the labor supply curve, isn't it?
Both, right?
Pardon me?
Would it be both?
Well, yes, it is both, but I'm trying to find this point
Okay.
that comes from supply. It was created by this one, so they do have a relationship. But that number I want to find right there is a supply relation. So now, knowing that, how would I find that number?
So you just plug 27 and a half in the labor supply curve.
Darn, that's exactly right. So, that's interesting. Is it, where do I plug it in? I don't plug it in here, do I? This returns to W, because it's W is what I want to know. It's on the W axis. So now what I have is 27 and a half is equal to this, right? Or 227 and a half is equal to 25W. Divide both sides by 25. 227.5 divided by 25 is going to equal 9.1, or 9.1 equals W. Does that make sense to me? Well, it's less than 10. It's greater than 8. Yeah, that might make sense. It's that point right there. And that point's going to be more relevant to us next week than it is tonight. But remember how you found it. Okay? Okay. I think that's most of what I really want to make sure that you know tonight from Module 3. Any other questions about this? Okay. All right. Cool. if I looked at this, L is equal to 500 minus 45W, how would I immediately know whether that was a demand or a supply curve?
Negative 45 means it's a demand curve.
Downward sloping. Yep, exactly. The negative sign in front of the scalar, in front of the W variable, tells me it's sloping down. And as it turns out, it is not sloping down at a slope of 45. I'd have to turn this back around into a point slope equation to identify how it's identifying what the slope actually is.
So how do you find that labor equation?
How do I find this labor equation?
Where do you get the 500 and the 45?
Well, the good news for you guys is it's given to you.
Given.
Yeah. Now, and in fact, it would be given to you all the way through probably even a master's level course in this.
Okay.
That comes from a survey and observations and regression analytics from entire markets. So you should never really have to create it. You might, if you were in an upper division version of this class, you might be given a table of values, like you've seen, and you might be able to infer it from the table. That you can infer it from the table if you've been taught how to do that. Okay. All right. So we know it's downward sloping because we know because of the negative sign. So we know it's labor demand instead of labor supply, right? And we know it's going to look something like this, and we know how to find the axes. So how do I find this number here, the W?
You can calculate it with the zero that is assumed.
Yeah, so I can make the supposition I'm at the zero nexus here. So if I'm on the W axis, the value of L is 0. 0 equals 500 minus 45W. 45W equals 500. 500 divided by 45 is equal to W. And I think we agreed that was 11.11. Okay? And similarly, if we're on the L axis, we know the value of W is 0. So L equals 500 minus, well, 0. So I know I'm out here. It's a downward slope. We will consider, when we get to elasticity, a slope that might not expressly seem downward, a curve that might be perfectly horizontal. Is that downward sloping? Well, not really. If it's got a slope, if it's horizontal, it's got a slope of 0, right? So it would be 0 times W, which means that goes away, which gives me LD equals 500. What you're going to learn has a particular elasticity connotation to it that I won't go into yet, but just remember that. In economics, we think that that's downward sloping. Why do we think it's downward sloping, Courtney? Any ideas at all?
So the labor demand is just the constant.
Yeah, you're thinking too hard,
Yeah,
Courtney.
I do that.
Yeah, it's okay. Any idea why we think that's downward sloping, Catherine?
Because it's labor demand.
Yeah, you're thinking as hard as she is. Mishwan, is it upward sloping?
No.
Well, it was slope 0, so we know it's not upward sloping, right? So it's quasi-downward sloping. That's how contorted economists are, by the way, all right? So we could argue that's downward sloping, but we could also argue the fact that it's not downward sloping means that it's quasi-upward sloping,
Yeah.
okay? Just know that. We're going to play that game in a couple of modules, all right? At least a little bit. Okay, so that's a curve. And even though it's a straight line, I'm going to call it a curve. If there was an exponent in there or something, then it would clearly be curvilinear, right? But there's not. So in this case, I want to talk about shifts of demand and movements along demand, okay? So I can have a movement along this curve. Let's say that I start here at some W and some L. I'm not saying that those are L star and W star because I don't know where labor supply is, so I don't know that's equilibrium. But I just have that point. What would have to change in order for this point to move upwards or downwards along this curve? And upwards means to the left, and downwards means to the right. Given this universe that's here on the page or the board, that is a W and an L universe, what would cause a shift or a movement?
Labor supply.
That's not, yeah, but what, yes, the imposition of a labor supply relation might tell me where W star and L star is, but that wouldn't necessarily move where that point is.
Gotcha.
What is it that could motivate a movement from that point to any other point on this line? Please.
Availability of labor.
You guys are thinking too hard again.
A change
Okay,
in W
you-
or L.
Pardon?
A change in W or
Yeah,
L.
any change in WRL, which might be a function of a change in demand for labor, supply of labor, all this kind of stuff, right? You just think a little too hard. So in this is because W equals something and L equals something, and it happens to end up right on that line. Okay? If W changes, goes up, then that point moves from there to here. W prime and L prime. Or if it goes down, I don't want to use X, I'll say W lambda and L lambda. Okay? It just, if W or L changes, then this point, we have a movement along the curve. But the curve itself didn't move, did it? It's in the same place. Our point has moved along it. Any change in anything else in the labor market other than W and L brings about a shift of the curve. A change in W or L brings about a movement along the curve. So now let's talk about what will beget a shift. Remember, a shift in this case might be a shift out and to the right such that at the same wage we demand more labor. Or it could be a shift in and to the left such that at the same wage we demand less labor. Okay, it's a shift. So what kind of conditions are going to cause us to demand more labor?
Increased capital.
Okay, so increasing capital, so that means increase in investment. We have new businesses created or expansion of existing businesses, and we obviously need workers to supply the labor to those businesses. Okay, so capital goes up. Labor units need goes up. What would happen if in the production of whatever the good is here, let's say that this is a market of workers that are oil rig workers. What happens to the demand for oil rig workers, wildcats and such, if the price of oil goes down?
Lose your job.
Okay, so let's think about that. If the price of oil goes down, do consumers buy more or less oil? We think they buy more, right? And if they buy more, we must have to produce more if it takes workers to produce. I think we just argued that it shifts out to the right. There's a reason that you said they lose their jobs. Because below a certain price, it doesn't make sense to produce oil, right? The cost is greater than the benefit, so we just shut it down no matter how much the consumers will buy. That's what you were referring to. What if interest rates go up in a market? What happens to the demand for labor? Let's kind of walk it through kind of like I did. So interest rates go up. Goods become more expensive for consumers to buy because they buy so often on credit. If it's more expensive to buy, we demand fewer of those goods. We demand less labor to produce them. And you're going to see through a number of the modules, especially the one in elasticity, you'll see me go through and kind of think it through like that. It's not that I don't have some of this memorized, because I do, as you would imagine, and you'll memorize some of this. But I purposely think it through every time, because there are some conditions in which these things don't always hold. Okay, especially when we're dealing with the concepts of substitutes and complements that we will deal with largely within the elasticity module. Okay? So a shift of demand a shift of the demand curve is going to come about when what is changed is not W and not L, but any other factor that could possibly affect the labor market. So Courtney, let's assume for a minute that there is a hurricane that's coming in off the North Carolina coast. How will it affect labor demand? So hurricane, well, I guess it depends on the kind of worker, right? So let's say it's construction workers. How will it affect labor demand? Hurricane, damage houses and businesses, need to rebuild, we need more workers to rebuild. The hurricane shifted the labor demand curve out. And if there was a labor supply curve that we could count on, we know that that would also not only increase the number of workers needed, but increase the price, right? Unless supply changed as well. Supply might change in response to that change in demand, because more workers might come into that market to supply it, in which case it might return to some equilibrium of some kind. So you can think it through like that, okay? In fact, if you're willing to think it step at a time, and always think back to what the change does to the good being produced by labor, and that then is going to help you know whether it's a shift out to the right, where at a given wage we need more workers, or in and to the left, at a given wage we need less. Sometimes people say, well, that's a shift up, because it looks like it's above my original condition, but up means out and to the right. I'll even use the term up sometimes, or down. Down means in to the left. What's up or down is the number of workers needed. Okay. Does that make sense? Okay. Let's come back and let's create marginal revenue product of labor equation. Let's assume for a minute that we have LD at 20 minus 3W. And I want to convert that to marginal revenue product of labor, and I want to find the slope of the labor demand curve. Okay? Because notice in here, the slope is not negative 45. Kind of looks like it might be, right? Because it's a scalar there, but this is an x-centric equation, and slopes are conditioned off of y-centric equations. So we'd have to revert that to a point slope form, which is y equals something, not x equals something. If I want to convert that labor demand equation, which I've told you, the labor demand and marginal revenue product of labor curves are the exact same curve in a perfectly competitive market. If that's the case, how can I convert that to a marginal revenue product of labor curve and thereby discover the slope? Bailey, do you remember?
Yeah.
Okay.
So, you want to bring that 3W onto the left side, right?
I do, but I need to do something else first. There's an assumption I need to consider. It's in a perfectly competitive market in which the curve LD is also MRP of L. So what's the competitive market condition that I can bring into play here?
So it's going to be,
Anybody can help?
So the MRP of L has to be equal to the wage.
Yeah. In a competitive market, in competitive markets, marginal revenue product of labor, or what labor contributes to the revenue spectrum, is going to be equal to the wage, which means workers are getting paid exactly what they produce for the firm. Okay? That's part of why it's competitive, or we know it's competitive. So I can then say LD is equal to 20 minus 3 MRP of L. And if it's an MRP of L equation, we now know I need to normalize on MRP of L instead of LD, right? So now I can add 3 MRP of L to each side. I can subtract LD from each side, and I end up with this. I can now divide each side by 3. MRP of L is equal to 20 thirds minus 1/3 LD. And now I know the slope of the labor demand equation. Negative 1/3. So for every one rise, so every one rise, I come down 3 labor units. Okay, it's define my slope. Okay, it's just good to know how to do that. That'll be useful to you in the future, I promise. All right? If I asked you why a labor demand curve is down, or why we know a labor demand curve is going to be downward sloping, how would you answer? We started with this, by the way. You might not have been here yet.
I walked in and it.
Did you? Okay, right then and there. Why is the labor demand curve downward sloping? There's like, you weren't here during that conversation, but would you kind of intuitively know why it's downward sloping?
Yeah, because I have lower wages from more workers.
Well, you know, and as it turns out, that's not why, that's a result of it being downward sloping. That's a very common answer. I would say that when I ask that question on an exam, more than half the students give me that answer, or on a problem set. That's a result of it being downward sloping rather than why it's downward sloping. What do you think, Catherine?
There's of the law of diminishing returns.
The law of diminishing returns. So as I have more workers, I believe my productivity goes down. If my productivity is lower, then I can only afford to pay them less, right? Unless I was paying them even less than they were earning for me before. But assuming it's competitive, if their productivity falls, I must pay them less. I can't afford to pay them the same amount. That's why. Okay? All right. I want to talk a little bit about the balance condition for a minute. But to do that, I want to kind of think about consumer economics for a second. So quantities and prices. Have any of you not had a consumer economics or basic microeconomics course? Courtney, have you had? No, okay. But you have, right? Okay. So this is going to be old hat for you guys. Some of the rest of this probably is too. But Courtney, I think you'll get this pretty easy. Okay? It just helps me set up why the balance condition I'm about to use is what it is. So in consumer economics, we're going to have something like quantity demanded is equal to 35 minus 5p. And the 35 and the 5 aren't magical. They're just numbers off the top of my little head. This is a constant. That's a scalar in front of the y-axis variable. Okay? Such that I can know that I've got a curve that's going to look like that. And that it might help me, that might help inform this. Now I can also think of it a little bit differently. I might think of it and say, well, you know what? With my budget as a consumer, I can afford to buy goods in society. And let's assume for a minute that I only have 2 goods in my society. I have good X1, I have good X2. And I have some budget that is equal to M. And I can spend my budget buying all of X2, or I can spend my budget buying all of X1, but I don't do that typically, do I? I buy some X2 and some X1, because I get some satisfaction from both of them. What is it that determines how many units of X2 and X1 I can buy? It's not my budget, because I can use all my budget on X2, or I can use all my budget on X1. So what is it that determines how much of each one I buy? Well, Courtney knows that we do that because a consumer gets some utility of X1 and some utility of from X2, or satisfaction, and we're going to try to maximize our satisfaction given our budget, right? In our little world, we only have 2 goods here. There aren't 3 goods, whatever they are. And I commonly might think of this as food and everything else. So I think I just covered all goods when I said that. Okay? Bless you. Well, what is it that helps me identify that I buy X1 prime and I buy X2 prime, so those are quantities of X1 and X2, and such that I'm on my curve, so I'm maximizing, I'm using all of my budget, right? and I have an indifference curve that measures my level of utility. You're just going to have to believe me on part of this, okay? I have a curve that measures my utility. I'm indifferent as to where I am on this curve. This curve is conditioned based upon my satisfactions of my utility as it relates to X1 and X2, okay? And this curve might look something like the marginal utility of X1 divided by the marginal utility of X2. If that curve might be set by that relationship. If I knew what those utilities are, and the marginal utility is you as a consumer, when you buy one more, get how much more satisfaction. Okay? One more of X1 or of X2. And it might be set like that. Well, there's a condition that lets me think about this. And the condition is, in this case, equal to the price of X1 divided by the price of X2. And the price is going to be what dictates my budget curve and how many units I'm buying at any point on the curve. And if I'm on this curve with my indifference curve set by this relation, and I'm on this curve with my budget set by this relation, if I'm there, I believe I've maximized my utility given my budget. Okay? So just kind of believe me in that for a moment, if you would. Now we're going to convert it to labor economics.
And utility is just one.
Happiness. You
One
satisfaction.
extra, is that what you're saying?
Yeah, so this is going to help me understand this relationship is going to create this curve, and it's conditioned upon the relationship by my marginal utility of one good versus my marginal utility of another. So if I buy one more of these, I can buy some fewer of these, right? So I've used my whole budget. And so I'm going to make those choices based upon how happy one more or one less make me. Okay? All right, so that's it. There's a little bit of an explanation in that to the extent that it needs to exist within the videos, but it's only a little bit of one. But that was a balanced condition for consumer economics. We balanced our utility against our budget, and when we get the most utility and we're using all of our budget, we are the happiest we can be. We can't be happier because we need more money to be happy. Okay? Well, we've got a condition within labor that helps us think about this as well. And it's the marginal productivity of labor, and we can think about that compared to the marginal productivity of capital. Labor is something we can change readily, right? If I don't want you to work for me in the state of Utah tomorrow, what? I can just say, you're done. There's no union that's necessarily going to be there to protect you, right? It's a right to work state. I can let you go because I don't like how you waved goodbye to somebody, or I can let you go because I don't have enough work for you, or because you did something wrong. But any of those things, right? I can even let you go for some reasons none of us would find appropriate. But I can change, I can hire new labor, I can let go of labor very readily in this market. Can I deploy new capital in my firm easily and quickly? Or does it take time? It takes time, right? I have to erase the capital. Let's say I want to deploy new capital by building another warehouse and doing another production facility. I got to raise the capital. I've got to get the permits to build the warehouse. I've got to order all the equipment, maybe have some of it special made in another country. I've got to bring it all in. It takes at least months. It might take years to deploy new capital. So under the premise that we get marginal productivity from something, labor or anything, by changing the units of input, I can't change these units of input quickly for capital. I can change the units of input for labor very fast. I can take this divided by the price of labor, which is wage, and this divided by the price of capital, which is the price of capital. And just like that consumer economics equation, I can find a point at which I have a balance. And what I'm measuring in this case is labor and capital. Those are the two goods that I utilize as a firm. I utilize labor to produce, I use capital to produce. I have a budget of some kind that actually is conditioned as my wage and price line. So I'll say wage and price line. And I have some kind of an indifference curve comes through here, which is my marginal productivity of labor divided by my marginal productivity of capital. So all I've done is rearrange this equation. I've multiplied both sides by W and divided both sides by NP of K to get these relations, right? And that's dictating where I am here. Cool. Understanding that relatively simple algebraic relationship then lets us think about something. If where I want to be operating as a firm is where these two relations are in balance, and that's optimal productivity given my budget and my preferences, my technology, then I have to think about what happens when I'm out of balance. Because do you guys think that the average employer sits out there and says, gosh, you know, I want to think about my marginal productivity of labor, my marginal productivity of capital, my price of each of these things, and I want to find the number of workers and wage, etc., such that it's equal. No, they don't do that. They're not sophisticated enough, maybe, or they're just trying to fight off the alligators that they get in the mail every day from bill collectors, etc. They're not thinking that. So how do I, if I have thought that, and if I find that I'm in this condition where, let's say, my marginal productivity of labor divided by wage is greater than my marginal productivity of capital divided by the price of capital, and if I want to bring this back into balance, what can I do?
You can increase the number of laborers.
Okay, so if I increase the number of workers, what's that going to do to my marginal productivity?
It will decrease it.
It'll decrease, and if the numerator decreases, the value of the term decreases, and at some point I come back into equilibrium, right?
Yeah.
Catherine, why didn't you tell me to employ less capital? Why did you tell me to employ less labor?
Because capital is fixed in the short run, so
Yeah.
it would take a long time.
It takes a while for me to be able to change this. Whereas if I've got this imbalance, I want it changed now. That's how I change it. Bailey, why don't I just change the wage I'm paying my workers?
Then you'll have unhappy workers.
Well, that too, but there's something else. By the way, I'll be less happy than they will if I change the wage I pay my workers.
Because you're a price, in a perfectly competitive market, the firm is a price taker. So
Yeah, I don't set the wage. So if you four are my workers, and I change what you're being paid, I'm going to go ahead and pay you $30,000 a year instead of $35,000 a year. You're going to look at me and say, you're out of your mind, because the guy next door will pay me $35,000 a year. I'm out of here, right? So I can't change that. Similarly, if it's a competitive market for capital, I can't change the price of capital. So this one, marginal productivity of capital, I can change it, but it takes me a long time. In competitive markets, I can't change either of these. The only one that's left is this. And Catherine pegged it exactly. In order to get a decrease in marginal productivity, you have to increase the units. So remember that. It'll be useful to you at some point very soon. Okay? And frankly, I think that's most of what I really need you to understand, other than what the videos will give you some inference on, with respect to labor demand. Do you have any questions? Okay. By the way, the videos go into more detail about this relationship as well. I encourage you to pay attention to it. It's not altogether intuitive. Okay, so now we're in the home stretch. Good evening. Tell by the look on Courtney's face, this stuff is just scintillating, designed to keep everybody right on the edge of their seats. Right, Courtney?
Mm-hmm.
Not so much.
So
I
I
get it.
actually have a question.
Yeah,
When I took, anyways,
she's about
So-
to confess that she's taken some of the review problems
Yeah, I
quizzes
did.
before the two.
I
This is
did.
the overachiever.
No,
It's okay, really.
I'm not.
guys.
I don't have any time to do homework during the week. I'm really busy. Okay.
Okay.
So on number 5, you ask if it had to be like a shift or a movement in the
Uh-huh.
curve. if the labor supply also changed, but couldn't, if theoretically speaking, if the labor demand curve was straight, like, wouldn't that change the wage, like, without, I don't know, I'd have to read the question.
Okay, well, I think I understand what you're saying.
Like, you see, because
I
I
think
got
that-
it
but
wrong,
let's-
but I was thinking that if the labor demand curve was vertical, then,
Well, even if it's not, even if
Okay.
it's not, I think you're saying that we have a point here where we've got W star and L star. And I'm asking you about a shift or a movement.
yeah.
And I say, if labor supply changes, let's say labor supply increases, such that it shifts out and to the right, will that cause a shift of or a movement along the labor demand curve? That's what you're asking about, right?
I think so.
Yeah. Okay. So what are the two things that can cause a movement along the curve? Change in wage or change in labor, right? Did wage or labor move before labor supply, or did they move as a function of labor supply moving?
Okay.
Function of, right? So not only do we have to think about the move, we have to think about what created it. Okay? So in this case, I wouldn't say that this was a movement. I would say this is actually going to create a shift. Here in a moment, you'll see why, of labor demand, because labor supply is not wage or labor. It was labor supply that moved, that caused these two values to move. Well, if labor supply comes out, and such that we have more workers at a lower wage, what's going to happen now to labor demand? Lower wage, firms can employ more workers for the same price, it's going to shift out as well. So we just saw a shift of our labor demand curve, not a movement along. Okay. Does that help?
Yeah.
One of the things that happens, especially those of you that are a little bit more used to economics, is you sometimes tend to think beyond the immediate. Okay?
Yeah, I was thinking, like, I think your question was asking the beyond the immediate one. Because I said movement and then the answer was shift. So,
Because in this case, it
Right.
wasn't a movement, it
Right.
was a shift.
right.
Okay.
But I was just thinking, like, anyways.
Got it.
But yeah, I see what you're saying.
Okay, cool. So let's talk about labor supply. All the rules, all the concepts of shifts and movements that we talked about with respect to labor demand also are true for labor supply. Okay? So we're not going to go back over those things. Why is labor supply upward sloping? Why is labor supply upward sloping? I think the answer that people want to give is, as I employ more workers, I need to pay them more. But again, that's a function of it being upward sloping. Okay? And it's not, I'm really not employing these workers yet, I just know that they're there, right? Or maybe it's a worker supplying more labor. So there's something else in this relationship we have to think about. So it causes us to migrate to the labor-leisure model, such that I've got both labor and leisure measured on this axis. And when I have 0 hours of leisure, how many hours of labor might I have in a day if I have 0 hours of leisure? Well,
24.
well, that's assuming I don't need to sleep or regenerate. So let's assume that we do, because most of us aren't Iron Man like you are. So yeah, I need some
8
sleep
hours
now.
a normal work day or something.
Yeah, so we're going to have, if I've got 0 hours of leisure, I think we can presume I've got 16 hours of labor, right? So I gotta have an 8-hour generation cycle of these. And if I have 16 hours of leisure, then I have 0 hours of labor. This is all in a single day construction. You could transfer this to a week or a month by having this be 16 times 5 or 7 or 30 or whatever it happens to be. Okay. All right. Here on this axis, I've got some dollars, such that if I've got a wage of 10, if I have 16 hours of leisure, Courtney, any idea how much money I'm making? If my wage is $10 an hour? How much money am I making if I have 16 hours of leisure?
160.
Well, I think that might be the case if I have 16 hours of labor. I don't get paid for sitting on the couch, do I? So if I have 16 hours of leisure, how much labor do I have? 0. So I'm making 0 right there, right? But if I have 16 hours of labor, now I've got $160 of wage. What I've just defined is a budget curve. A consumer, remember, has 2 goods. Well, a worker has 2 goods that they're really most interested in. And we're supposing those goods are money and leisure. Catherine, I didn't meet you before tonight, right?
Right.
I believe that I can ask you one question, and it's not how much you make, and by your answer, I can know exactly how much you make. Do you think I can do that without asking you how much you make?
No.
Okay. I think I can.
Okay.
How much will it cost me for you to give up an hour of leisure? Do you ever give up an hour of leisure?
Yeah.
And to whom do you give it?
My job.
And how much do you charge for it? Don't answer the question, but all of a sudden, without asking you how much you make, I know how much you make because you give up an hour of leisure for whatever wage you receive per hour. We don't charge for our labor. We charge to give up leisure. And that's just the opposite of what we most of the time think, right? We give up leisure when we are at labor. That's why this relationship becomes so important to us. Okay, so here's my budget curve. I can use all of my time at labor and make 160, or I can use all of my time at leisure and make nothing. What dictates how many hours a day I'm going to work, assuming it's completely my decision? I don't have an employer say it's got to be 9 hours, 7 hours, or 10 hours. I don't have any regulations telling me it's constrained or not. You'll notice I haven't adjusted for overtime here, right? What is it that helps me decide how much labor I'm going to give or how much leisure I'm going to give up? Bills. My need, right? I think so. In fact, I have an indifference curve. An indifference curve is the same one that we looked at for the consumer a few minutes ago. I'm going to say you, Courtney. It's a utility curve for Courtney. And Courtney, on this curve, at any given point on the curve, you are as happy as you are at any other point on the curve. That's why you're indifferent as to where you are. You can be up here, be out here, you can be right here. You have the same level of happiness, satisfaction, utility, marginal utility at any point on the curve. In fact, the curve might be dictated by this balance condition issue. We've got the marginal utility of labor and the margin divided by the marginal utility of leisure, and that defines this curve because we only have 2 goods, labor and leisure. We have to worry about. Okay? That's what defines the curve. Well, let's assume that we're right here. And it gives us a relationship here. And let's assume that my budget need is a function of the price of leisure versus the price of labor, or the utilities for them as well. So that's going to define my curve here, right? And actually, in this case, price of labor is wage, right? It defines my budget. And I've got my indifference. And let's say in this case that my need is equal to 120. My budget requirement is 120 to pay my bills and be happy and not hounded by bill collectors and not starving. Well, if that's the case, how many hours will I work? How many hours of leisure will I give up? Well, if I need to make 120 and my wage is 10, apparently I'm going to work 10 hours, 12 hours, excuse me. And if I've worked 12 hours, how much leisure do I have left? 4. Because these numbers must equal 16. There is no choice. This is a labor-leisure trade-off model. It helps me accurately identify some things. And in this case, if my utility came along just as suggested, my indifference curve is going to come up, right, it's going to transact right there. Courtney. It's going to look like this. Okay? Well, okay, Courtney, let's say this is you. You need $120 a day, and that satisfies you. For whatever reason, you're okay working 12 hours a day in this case. For some people, that's no big deal. I work 10 to 12 hours a day pretty consistently. I less than that, I just don't enjoy it, and I like to work. Okay? So that being the case, let's assume now, Courtney, that somebody came along and left you an inheritance. And that inheritance gives you $50 a day without you even needing to get out of bed. Okay? It's an endowment, an annuity, let's say. Now what happens to these numbers? You're still making $10 an hour. If you work 16 hours or give up 16 hours of leisure, what's the top line value here where we cross our dollars access? Anybody have an idea? Well, if you work 16 hours, $10 an hour, you can make 160 bucks, right?
I was gonna say, is it still the same?
Well,
just add
it's the same from labor, but I also have the endowment. So this is my base. In fact, I'm going to take that which I create from my labor or giving up leisure and add it to what I create just because I get out, or just because I exist, because this inheritance is yours every day. Rain, shine, work not. Okay. So now, this became 210. Right? Well, now if you've got a $120 need, are you still going to work 12 hours? And let's assume all you want to do is satisfy your need. Well, I don't think so. I think we're going to satisfy $50 of that need immediately just because the money's there. So you only have to work 7 hours.
But why did you change it to 210?
Pardon?
Why is it 210?
Because $50 comes from my endowment, the gift, and I can earn 160 by putting in 16 hours of labor at $10 an hour. And so it's additive. Okay? Good. No, good question. No, you need to ask these things, okay? So that's why this became 210. All right? Well, if this is the case, I have a $120 need, 50 is satisfied immediately. I only have $70 I need to earn. So I'm going to work 7 hours. That means I'm going to have 9 hours of leisure to end up with my same $120. And this effect of having this extra endowment and it bringing about less labor on my part is referred to as an endowment effect. Okay? Okay, fine. I'm all right with that. It's the effect of an endowment. What would be the effect of overtime instead of an endowment in our labor-leisure trade-off model? Let's assume that there's an overtime kink at 1.5, which means for every hour I work beyond a certain point, I get time and a half, or in this case, $15. And it's everything beyond 8 hours. Well, in that case, I know that at 8 hours of labor and leisure, I get 80, right? But what do I get if I've got 16 hours of labor? Well, I've got another 8 hours times time and a half, so that's another 120, right? Which takes me to a total of 200. I'm going to put this higher on the curve so you can observe the kink. Say it's all the way up there, such that my curve comes and I have an inflection point here as my OT kink. That's representative of where I go from straight time at 10 to time and a half. The slope, by the way, of this is negative of the wage. So down here in the lower part, it's -10. Up here in the upper part, it's -15. The slope of the labor-leisure budget curve is the negative of whatever wage is applied at that point. Well, in this case, I've still got my $120 need. The first 8 hours is going to satisfy 8 of it. So I've got 40. How many hours am I going to put in if I have 40 more dollars to earn? Well, I have $40 to earn. It's $15 an hour I'm making now. So that's just a little bit less than 3, right? Okay. So I'm going to put in a little bit less than 11 hours in order to make my $120. Okay? So you start to see the effect of the labor-leisure trade-off, see the effect of different compensation mechanisms, see the effect of endowments. We can model out the effect of unemployment, let's say. Let's assume for a minute that I have a worker making $40 an hour, such that if 0 hours of labor, $0, but 16 hours of labor is going to give me $640. If this worker is working 8 hours, they're making $320, right? If that's what they're doing. And now the worker becomes unemployed. And unemployment, in this case, is designed to give this worker half of a regular day's wage, or 160. If you're unemployed and you receive your unemployment benefits, say in the state of Utah, how many hours a day are you allowed to work? 0, right, Catherine? To get the unemployment benefit. This is what the unemployment relationship looks like, suggesting that if I work 0 hours, I get my $160 benefit, half of my normal day's pay. But if I work anything more than $60, I don't get that benefit, and now I'm simply getting what my dollars per hour are. Disability insurance most often works the same way. If you work at all, you're no longer disabled, you don't get the benefit. Now there are some programs that might say, okay, we want to incent you to work some. We want to tell you that if you work, then you're going to get something of your benefit and something of your wage. And so it may end up being on a relationship like this. And you can think about this quantitatively, or you can just think about it graphically, and it creates the quantitative nature. So there's a lot of different ways of looking at the labor-leisure trade-off model. make sure you're good in terms of how you deal with the endowment, okay? The endowment plus the dollars that you might earn from working 16 hours is what's going to dictate the top of this curve when you have that endowment effect. The endowment creates a foundation, a base you can't fall below. Okay? An endowment can be thought of as an automatic stabilizer. What's an automatic stabilizer in the labor market? Do you know?
Floor.
A floor of some kind, yeah? What might be an example of one? Pardon?
Minimum wage.
Minimum wage. It's a bit of a stabilizer. It's not exclusively one because I might earn nothing if I don't have a job, but at least it's a floor below which wages won't fall if I do have one. What's another one?
Unemployment.
Unemployment insurance. I'm out of work, I still get something. We modeled it a second ago, right? And so I've got some stability even if I don't have a job. Why do we as a society, why are we willing to pay unemployment benefits? Which sometimes is a function of the insurance that we bought from with the unemployment insurance premiums our employer pays for us. But sometimes it's beyond that, right? It wasn't very many years ago that the regular 52 weeks that's available of most unemployment insurance plans was extended, or rather 26 for most, was extended to 52 and then extended to 99. And it wasn't that there was more money put into the unemployment insurance system by our premiums, there were tax dollars put in there. Why did the government utilize our tax dollars to extend unemployment insurance benefits?
So people wouldn't fall out of the labor market?
Well, they would still be unemployed, but they'd be
Right.
looking, right, so they're part of the labor market. There's something beyond that, though. So if we are the economy, and two of you aren't working and you have no income, what happens to GDP?
Goes down.
Goes through the floor right with you, right? What happens to crime?
Goes up.
You have households, families, needs, it goes up. So there are costs to society when these things take place, and it's incumbent upon us to offer some stabilization. It's interesting, here in Utah we have a really kind of a unique automatic stabilizer because of the influence of the LDS Church. You guys, some of you may be members of that church, maybe not. But it's kind of interesting because if I'm out of work and if I happen to be a member of one of the LDS congregations, then I might be able to have some welfare from my congregation. It's not thought of like welfare generally, and it operates as an automatic stabilizer here in this state. Have you ever wondered why our unemployment rate is lower than the unemployment rate nationally almost all the time? Part of it is not because we have such an interesting unemployment insurance system. It's not because people want to work all the time. It's that when there are shocks to the economic system, that additional stabilizer that we have causes consumer purchases to remain relatively robust, which causes people to need to work to provide the goods for the consumers. It's really kind of interesting. Okay. What's an efficiency wage? Do you know?
Like maybe like a commission type of thing?
No, not exactly. In fact, it's actually rather different. We're going to talk about it in detail in another module, but I like to introduce it here. So you guys know Henry Ford, right? Well, you know of Henry Ford. And you've probably heard the story that in an early point in the production of Ford motor cars, workers didn't get paid very much. Turnover was rampant because they'd gone from doing custom production of goods to production line. And you just stood there and you tightened the same bolt every 2 seconds as it came in front of you on the production line, or whatever the time frame was. And it's kind of boring. A little bit like call center work today, I think. Okay, maybe. And it wasn't very well paid. Turnover was terrible. It was hard to keep people, hard to get them trained, they go away. So it was a problem he wanted to solve. And Ford said, you know what? I can afford to pay more than I'm paying right now, which means the marginal revenue product of labor was greater than the wage. Okay? You can afford to pay the marginal revenue product labor. I can afford to pay more. So I'm going to pay more. I'm going to double my workers' wages. And when he did that, he motivated people to stay longer. They became more experienced. They did a better job. Production went up. Quality went up. Turnover went down. But his wage bill went up, right? And we would say, in some respects, that's a problem, but because his productivity went up, it was okay. Well, he was genius. Not just because he offered this wage that we are going to call an efficiency wage, and I'll define it a little bit better in a moment, but because he coupled this with something else. Prior to this time, it was unheard of to purchase an automobile with a loan. You just paid cash. Well, most of us, when we buy a new car, we don't just pay cash today. Most of us will get a loan, right? I want my new $75,000 BMW, which sadly is a low-end BMW, right? And I don't drive one. But I want my $75,000 BMW. I go borrow money to get it, and I make a monthly payment. That was unheard of at the time. Ford said, you know what? I want my workers to not only have more income and stick around longer, be more productive, etc. I want them to be able to buy my product. So simultaneous with this formation of efficiency wage, he went ahead and lined things up so that if, Catherine, you worked for him, you could buy a new Ford and you paid for it out of your paycheck with this additional wage or some of this additional wage you just got. And if you left the company, you had to pay off the loan. So that motivated you to stay longer still, right? Because it wasn't a 6-week loan. It was a couple of years, what happened. Simultaneously, he increased his productivity. He increased the wage to his workers. He was a hero because he was paying them more. He put a car into every one of their garages, and they stayed longer. He was an absolute hero. And what happened to his revenues when he put a car into every one of their garages? He had 300,000 workers at the time. It was brilliant. Well, an efficiency wage is a wage above current W star, but equal to or less than the marginal revenue product labor. Well, let's look at this. Pens?
So is it pretty much just creating value in a different way?
Yeah, he did too. Got as smart as a whip. He also, do you know much about Henry Ford? Do you know much about his politics and such? He was anti-Semitic, terrible.
It was like pretty nuts.
Yeah, he had some real problems growing up in his little head. But he was also brilliant. Okay. So if this is our marginal revenue product of labor, and if we're here at W star, we could possibly somehow choose to pay more than W star. We could pay some W up here. Now there's another condition that we'll talk about later on that helps with this. But any wage in between this spread, and the other condition has to do with labor supply and marginal expense of labor, okay? I just don't want to get too complicated here. Any condition in between those where a wage is above the market clearing wage, but at or below the marginal revenue product of labor, is considered an efficiency wage. A wage the employer can afford to pay, but doesn't have to pay. Well, if they can afford to pay it, we must have a non-competitive market that's brewing. So when we get to non-competition, you'll better understand this. I like to introduce it here just so in the back of your head you understand something of it, so when we get there it's not wholly new to you. I think that's most of what you need to know to deal with. Now there's some other questions on the review problems and such, but I think this is the part that's harder to understand. What kind of questions might you have? Okay. So next week, if I remember correctly, we go into modules 6 and 7 where we talk about friction or non-competitive markets, and we talk about elasticity. And then beyond next week, we have an exam as our midterm.
I actually do have a question. So
Yeah.
when you say the labor supply curve is upward sloping, it's because You have to pay more people more to get rid of
Thank
more of
you.
their leisure time?
Yeah.
Okay.
Because if you want me to think about scarcity, and I opened that door and I never closed it, so thank you. So think about scarcity. If you want to get me to supply more of my labor or less leisure, and leisure is a scarce commodity, if I'm going to give up more leisure, you are going to have to pay me more to do it, because it's a scarce commodity. And when something becomes yet more scarce, it becomes yet more valuable. So it's not because in order to get people to work, we pay them more. That's a function of upward sloping. But if you want me to give up more of my leisure by working more, you're going to have to pay me even more because leisure is scarce. Because we only have 24 hours in a day, and we suppose we need at least 8 hours to reject. Thank you for taking this. Okay? All right. I think we're clear.